Hello, my name is Sigrid Elsenbruch. I'm the PI of project A10, and my background is in experimental biological psychology. My great interest is in visceral pain and the question how visceral pain is learned and then how the memories for visceral pain are formed and possibly reactivated. The clinical background lies in chronic visceral pain, such as in irritable bowel syndrome or IBS, where patients have constant or recurrent gastrointestinal pain. So the brain constantly receives signals from the gastrointestinal tract coming up, and normally these signals are not perceived, but when they are perceived, they are quite uncomfortable, and that makes visceral signals or visceral pain such a biologically relevant, such an important signal that is probably preferentially processed within the brain. So what we are trying to find out in this project is how pain-related fear is formed and extinguished, especially for this important and salient stimulus, the visceral pain stimulus. How do we do this? We have a validated and established model to induce visceral pain by using pressure-controlled rectal distensions. So a balloon is distended in the rectum, and that really is very similar to the pain that patients with IBS feel. And using this visceral pain as US, we can study how pain-related fear is formed and subsequently remembered within specific brain regions, especially the extinction network. What we want to know, especially in our study 1, is whether this memory for visceral pain is specific for pain modality and whether it is stronger and perhaps more permanent compared to another relevant US, a somatic heat pain stimulus. And what we will then try to find out if the visceral memories are particularly altered in patients with chronic visceral pain, so patients with IBS. Therefore, in our first study, we will compare learning and extinction in IBS patients compared to healthy controls. In this study 2, where we're going to implement a new interoceptive conditioning paradigm, we'll use the background colors of the MR scanner combined with the lighting to create different contexts so that we can context-dependently elicit renewal effects. So the method for this new interoceptive conditioning will be new. We will pair barely perceptible conditioned distensions with different background colors of the scanner to create a unique context. So in some contexts, the visceral distension as CS will predict upcoming severe pain, and in another context, the same visceral CS, so the barely noticeable distension, will predict safety from pain. And in the renewal condition, these CSs will be shown in the original learning contexts. The third and final planned experiment is also clinically relevant because we know that patients perceive more stress and they suffer from chronic stress that exacerbate their visceral pain. And nothing is known how stress or stress mediators of the hypothalamic pituitary axis affect pain-related extinction learning. So in a first step in healthy subjects, we will implement a study with hydrocortisone, so the major hormone of the stress axis, and test this on extinction and reinstatement processes using our visceral pain model. In all 3 studies, we will perform brain imaging to study the extinction network during acquisition, extinction, reinstatement, and renewal of visceral pain-related fear. In parallel, we will acquire behavioral ratings, such as Valings ratings of the conditioned stimuli, pain ratings and aversiveness ratings of those USs that we will implement, and we will measure skin conductance responses to assess differential peripheral responses during extinction learning. So together with these studies, we want to learn more and go further beyond what we have learned as part of the research unit that has really laid the basis experimentally for this line of work. And we want to find out how the visceral modality, how interoceptive stimuli are processed within the brain and how these memories for these salient stimuli are formed and how they can be reactivated. This will be clinically relevant to understand the pathophysiology of chronic pain, especially of chronic visceral pain, but it will also teach us important lessons about how the brain remembers and learns about signals coming from within our body, with many implications for conditions characterized by interoceptive signals. Thank you very much for your attention and interest in this project. Goodbye.